Yeah, hello, I'm Guenther Schmuelling from Microsoft, and I do have some converter updates for you. Let's start with the PyTorch Exporter. The PyTorch Exporter is supporting PyTorch 1.8, and it's supporting offset 13. The team has added support for 12 more new PyTorch operators, and it updated the support for 10 existing operators. It added support for optional arguments in the models format method, and it added better support for script model. For example, shape and type inference for the PyTorch graphs during the export. And you'll find more detail on in the PyTorch release notes. Then we move on to sklearn-onnx. It also was updated to offset 13. It supports now int8 and uint8 as inputs. It has better support for numpy.metrics and a bunch of random changes, which you find in the slide deck. And then for TensorFlow to ONNX, we support TensorFlow 2.4 and offset 13. We added support for TF-Lite, so you can now take a TF-Lite model as input into TF to ONNX and convert it directly to ONNX. We do support quantization via QDQ, and we have an example in our tutorials section, and the link is in the slide. We noticed that more people start using TF to ONNX to convert Keras to ONNX. And many of those seem to be using the Python API. Our old Python API wasn't very user-friendly, so we refed our Python APIs to make this much easier. So you can now take any in-memory model in TensorFlow or Keras and convert it, call the new Python API and convert this way. We made some changes to avoid using having the converter use the GPU during the conversion, so it doesn't interfere with the model that's already on the GPU. We did a lot of testing for TensorFlow Hugging Face models, and we published some examples how to do this to make this a little bit easier for people. And we added support for structured outputs in TensorFlow. And this fixes the issue where you have a Keras model and the output names don't match the Keras models. And then we added a bunch of random fixes and added support for additional operators in TensorFlow. And with that, I hand over to Kevin to talk about the TensorRT converter.
Thanks, Guenther. Hi, everyone. My name is Kevin from Nvidia, and I'll be giving a quick update on the ONNX-TensorRT backend. Since the last update, we have moved to monthly container releases for ONNX-TensorRT, and some of the highlights over the past 2 releases are that we've added support for 8 new operators, and we have also added support for offset 13 definitions of existing operators. We have also open sourced our Python bindings for the ONNX-TensorRT parser, so you're feel free to check that out when you have some time. As for the next major release of TensorRT, it is planned for May 2021. And some of the highlights here is focus on improved ONNX QDQ tooling and support, as well as improved out-of-the-box performance for various NLP models. Finally, for tooling updates, we actively maintain various ONNX-related tools, and we encourage you guys to check it out. First is ONNX Graph Surgeon, which is a Python library that provides a simple and intuitive interface for the creation and modification of ONNX graphs. Second, we have Polygraphy, which is a ONNX backend runner that can load ONNX models and compare as well as accuracy as well as performance numbers between different ONNX backends. Finally, we have the PyTorch QAT toolkit, which allows users to train and evaluate PyTorch models with simulated quantization, export to ONNX, and then run inference with TensorRT. Now I'll pass it off to Chen, who will provide an update on other backend converters.
Thank you, Kevin. I'm Chen from IBM. I will talk about TensorFlow backend and share a couple of roadmap ideas we have discussed. For the TensorFlow backend converter, we have added model testing for all model zoo models. It is part of our CI now, and the conversion results are published to our GitHub wiki, as you can see in the link. We just completed the offset 13 support, and we'll have a new release pretty soon. Another new feature is a simple training scenario that is based on the ONNX inference graph, including a few examples as well. Yeah, as for the next ideas and items, we will look into offset 14, ONNX native training, and possibly TF Lite to some extent. Next, please. Yeah, as for the roadmap ideas, the first one is a common question. How do we support channel last data format in ONNX? As we all know, currently a few ops require the data format to be channel first. That includes operators like conv, pooling, resize, and batch norm. This leads to two situations that can be optimized. One is if the model input is channel last, some data transformation has to happen in the model. Two, if the backend prefers channel last, which is common for many edge devices. Again, some sort of transpose will be inserted into the model to make it less efficient. So providing a new data format option would make the ONNX models more flexible in general, and also more friendly for certain backends. The last one on the list is that we would like to explore a sort of a standard model zoo test for all backends to ensure high quality conversion. So the community can easily see not only the operator level coverage, but also the successful rate for converting real world models. All right, that's all we have today. Thank you.